was cold outside, but now I have this lovely fire right here and my dog. So I'm going to sit back and record this podcast. I want you to sit back too and enjoy what's coming. All right, so just a couple miscellaneous things to finish up in this podcast. And basically, if you hear the word isoelectronic, all that means is that they have the same number of electrons. Not the same number of valence electrons, that they have the same number of electrons. A lot of times that shows up on the AP exam. Which of the following are isoelectronic? So you know that oxygen, fluorine, those kinds of things actually gain electrons. And then sodium, magnesium, the metals, they tend to lose electrons. Oxygen, fluorine, sodium, magnesium, aluminum, all of those have the same number of electrons. But we would talk about which one is the largest ion and which one was the smallest ion. Obviously, the more electrons you gain, then the bigger you are, and the more electrons you've lost, the smaller you are. And that has to do with the effective nuclear charge. How much is that nucleus pulling in on those electrons? So aluminum has many, many more protons than oxygen does. The other thing that you're likely to see is something called lattice energy. Lattice energy is just the energy that's released when two things form an ionic compound. So when you take a metal ion as a gas and a nonmetal ion as a gas, and they form to make a solid, when they form that lattice, they release a certain amount of energy. And what that tells us really is how strong things are. The higher the lattice energy, the more energy released, or conversely, the more energy it would take to break those things apart. We calculate lattice energy using this equation right here, and it's called Coulomb's law. And Coulomb's law basically says it's a function of charge and the radius. In class, we'll practice this a little bit, who has a higher lattice energy. But you guys just need to be able to see who's got the stronger energy of a bond. And that all relates to the distance between the ions and also how much of a charge is on there. There are four types of solids. There are metals held together by those metallic bonds, that sea of electrons that no one really wants. The book calls them delocalized electrons, but what that means is they don't belong to any one atom. They're kind of just floating out there between atoms. There's ionic, which is between a metal and a nonmetal. There's molecular, between two nonmetals. And then there's covalent network, and you may not remember that very well. So I just wanted to tell you guys a couple that are very, very important. Diamond has carbon that is nothing but covalent bonds between them. And silicon dioxide, or what you might also call quartz, has nothing but those covalent bonds between them. On the top left, you'll see silicon dioxide, and on the bottom right, you'll see diamond. With nothing more than covalent bonds, this means these two have the highest melting point of anything. If you see that on the AP exam, what has the highest melting point? You're going to look for silicon dioxide, or quartz, or diamond, because they're nothing but covalent bonds all the time.